Okay, guys. Starting Unit 2, we're going to do all of Chapter 7, and we're doing one other section, which is 3.1. And just like in the last chapter, we're going to come back to 3.1 a couple times. But we're going to spend a couple days on it now, and hopefully it'll be a nice way to start this unit. And so 3.1 is about graphing systems of linear inequalities. And so starting out, just to remind us how to graph a linear inequality, again, slope-intercept form, y equals mx plus b. We start with the y-intercept, and then we use the slope. The difference between an equation and inequality is that it's not just the line itself, it's the shading, right? So 2x plus 3, that's a y-intercept of 3, and a slope of up to over 1, or down 2, back 1. And also remember with inequalities, it's all about a dotted line or a solid line. So since this doesn't have a line underneath it, it's just less than, remember that it's going to be a dotted line. And then it's less than, so less than means below the line. Or remember, if you want to check that a point works, you just point it in, plug it in to see where it works. So like I would pick 0, 0. 0 is less than 3. That's true, so that's why we shade here. What does that mean? It means every point in this shaded area is a solution to the system, all the way up to the line, but the line itself is not included, okay? A couple other ones I wanted to remind you of is what if it's just one number, like an x equals number or a y equals number? Remember, x is equal to 3. What would that mean? That would mean I would go on the x-axis to 3. And where is x always 3? Or think about the slope of this. The slope is undefined. So this is a vertical line. And that's where x would always be 3. Because it has a line underneath it, because it's included, it would be a solid line. And because it's less than, where would less than 3 be? Well, less than 3 would be behind 3, like 2 and 1 and 0. And so all of this would be the answer. And if I had the line y is greater than 5, think about that. That's like 0x plus 5. So the difference between an undefined slope and a 0 slope, we would go on 5 on the y-axis. And y would always be 5 horizontally. But because this one's not included, this one would be a dotted line. And where would greater than 5 be? Well, that would be like at 6 and 7. So that would be above 5. So I'm going to shade above the line. Okay, so just a nice little review before we get to the systems. And remember, a system of inequalities is when you graph 2 or more equations on the same graph, and we want the solution where all the points satisfy each inequality. Basically, we're looking for where the shading overlaps. And look, I forgot to put a graph on this one, so I'm going to add my graph. You don't have to draw your own graph, okay? So step 1 is I need to put these in slope-intercept form. So the first thing I'm going to do on this is I'm going to subtract 4x, and I'm going to get 3y is greater than or equal to negative 4x plus 12. And then I'm going to divide everything by 3 to get slope-intercept form, and I'm going to get negative 4/3 x plus 4. Excuse me, got a little choked up. So if I'm going to graph this, I'm going to go up here to 4 on the y-axis, and I'm going to go up 4 and back 3, or I'm going to go down 4 and over 3. This would be a solid line. And I'm going to shade in different colors here, so you're going to be able to see the overlap. But if you want to not shade yet and wait for the end, you can do that as well. Or shade lightly here is what I would say, because we got to see like where the overlap is. But this would be greater than, and greater than would be above the line. So greater than would be like this. And then if I change colors here, on this one, I would subtract x over. But remember on inequalities, when you divide by a negative, that you flip the sign. So that's a really important thing to remember. So this now switches to greater than or equal to positive x. And again, think about the y-intercept here is there's nothing here, right? So that's a y-intercept of 0 and a slope of positive 1. So up 1 over 1, up 1 over 1, right? And so then that's going to across like this. And everything greater than that line would also be everything above that line. So what is the solution to this graph? The solution is where that shading overlaps. Like where is both the red and the green? Or if you shade like this on your paper, lightly shade, where does that shading overlap? And so I'm going to make it very obvious where it's shaded here. And I'm going to say it's everything that's both above the red line and above the blue line. And so this would be the solution. Okay, and that's really all we're doing for this first day. So just some kind of review of graphing and shading, and then we'll go from there tomorrow.